Hi Andy, good morning. This is again Dr. C.H. Kiran Kumar dealing you the machine learning part. Today let us discuss about what is called association rule mining, my dear friends. Association rule mining. Right. See, we have already seen, we have right. For example, let us take a transaction like this. Now, in this, we want to find out frequent set. Frequent set mining. This is also called as frequent set mining, my dear friends. Right, let us see this now. This is an unsupervised learning. This is an unsupervised learning, number one. And then, suppose we observe 8 customers who bought one or more of apples, beer, crisps, and nappies, for example. Right. Let us take this as an example. Now, right. Frequent item sets. Now, item sets. Each transaction in this table involves a set of items. See, first transaction, nappies. Second transaction, beer and crisps. Third transaction, apples and nappies. Fourth transaction, beer, crisps and nappies. Something like this. And fifth, right. Conversely, for each item, we can list the transactions in which it was involved. For each item, for example, apple. See, for each item is apple, we can list the transactions in which it was involved. What are the transactions involved here? Apple. See, third one, and then fifth one, and then sixth one, and seventh one. So we can write it as 3, 5, 6, 7. So this is right. So we can write like this, right? See, each transaction shows. Right, next. Transaction 1, 3, 4, 6 for nappies. 1, 3, 4, 6 for nappies. 3, 5, 6, 7 for apples. 3, 5, 6, and 7 for apples. Right. Similarly, we can easily find out what are the transactions for every item. Right, we can also do this for sets, my dear friends, sets of items. For example, beer and crisps, rendu kalipi. For example, right, beer, number 2 okati, number 4 okati, number 6. There are 3 things. 2, 4, 6. 2, 4, and 6. We say that the item set beer crisps covers transaction set 2, 4, 6. This is terminology, my dear friends. So we say that set beer, crisps covers 2, 4, 6. Right. There are 16 of such item sets. 16. Why? Because, see, we have nappies, beer, crisps, apples. There are 4 items. So, we will get 2 power 4 item sets. 2 power 4 means 16. 16. So totally including the empty set, which covers all transactions. So if you write, see, normally if you can write, see, 0, 0, 0, 0. 0001. So, ante, if there is a 1, you write the corresponding one. If there is a 0, don't write. So in that case, this is called empty. This is called empty. This is only having nappies. So 0010, if you say this is beer. 0011, we can say this is nappies, comma beer. So in that way, we can see all 16 transactions. So why I am telling you the 4 zeros and all? Because you all have gone through DLD and all. So easy. Anyhow, so this is how to 16 combinations we can write the 16 combinations. Right. This is called the right. You can see the total display of this particular thing. Right. 16. Right, children. Now this is single items, 2 items, and then the 3 items, and then the last one is 4 items. See the total space. Right, we'll find out how to evaluate all these things. Right, we'll see. Just this is empty set, my dear friends. This is empty set. That is all zeros. This is 0001. This is 0010. This is 010. This is 100. Something else. Hope you understood, right? Right. Next. Now, let us call the number of transactions covered by an item set 1 as its support, denoted by SUPP of I. SUPP of sometimes called the frequency. SUPP of I. We are interested in frequent item sets, which exceed a given support threshold F0. I'll give you a threshold F0. For example, F0, see, we'll see. Right, that is called threshold point is 3, my dear friend. So threshold point is F0. And support is the number of items, the number of transactions covered by an item set is called its support. For example, what is the support of nappies? Is equal to 1, 2, 3, 4, 4. So we can say nappies is 4. Support of nappies is 4. Sup of. Right. Similarly, if F0, what is threshold? Threshold means, so threshold, suppose if there is a 1, only suppose if you take beer or no combination. For example, if you take combination, apple, beer. Apples, beer. How many are there? See, this is not, this is called, so maybe only 1. Only 1. Now threshold means, I will give you a number. You have to take combination such a manner that whose count is greater than the given threshold. So in that case, you will not be selecting apples, beer. So among the 16 combinations, we are eliminating some combinations by using threshold, That is the main idea of threshold, my dear friends. Threshold, that is the main idea of threshold. Right. Now, Now, right, support is monotonic when moving down a path in the item set. That is, it can never increase. This means that the set of frequent item sets is convex and fully determined by its lower boundary of largest items. Let us see what is all these things. In the example, these maximal, no supersets, frequent item sets are, say for example, F0 is 3. F0 is 3. That is threshold is 3 for this. And suppose if you take apples. Now, what are the three things we have to take? What are the things we have to take? See, no supersets, right, my dear friends? Right. First, you take nappies. Nappies. Because nappies, do you have 3? More than 3. We should have at least 3. Nappies 1, 2, 3, 4. So we can take nappies. Oh, okay, nappies. Apples, you take apples. 1, 2, 3, 4. So apples also taken. And so let us take so nappies we have taken. Beer crisps. Beer crisps, if you take, this is 1, this is the second one, and this is the third one. So it is written as 2, 4, 6. So at least 3 transactions involve apples. See, at least 3 involved in nappies. At least 3 involved in both beer and crisps. Any other combination, it was bought less often. So any other combination was bought less often. This is how we have to calculate the score. Right now, let us see an algorithm for finding frequent item sets. My dear friends, this is nothing but our breadth first search. You have already learned this in your data structures or DA. Data structures are DA. Here we maintain a queue, what is called queue, priority queue. Hope you understand what is a queue. First in, first out, FIFO. First in, first out. Whichever is sent, that will come out first. So insertion is done in the beginning, deletion is also done in the beginning. That is called queue. Here we maintain a queue, my dear friends. We maintain a queue. And we initially send all set of, right? We initially priority queue contain the empty item set. Nothing will be there. Empty item set. That's what? 4 zeros. That is empty item set will be there in the queue. That will be there. So while queue is not empty, there is one empty set is there. I is equal to next item set deleted from front of queue. Then max is equal to 2 for each possible extension of I dash of I. If support of I dash is greater than or equal to F0, if support of I dash greater than F0, then max is equal to false. Add I dash back to Q. So I dash will be, if support of I dash is greater than F0, then our Q will get that Q. If this is our Q, so I dash, this will be I dash. Right, and max is set to false. Now we repeat. For each possible extension I dash, my dear friends, for each possible extension of I dash of I do, if support of I dash is greater than or equal to F0, then max is equal to false and add I dash to Q. I dash to Q. So we can add many values will be added to this Q. Now we have to go back. I is equal to right. Next we added I dash, no? We will be deleting that. Whichever is added in the beginning, that will be deleted. And Dani yokka, see, Dani yokka again, we will find out. See, for example, in the above case, in the above example, what are the nappies? Nappies is there. Suppose nappies. So, whenever support of nappies, right? We will take for the first transaction and I dash nappies, the support of I3 is greater than 3. So we will be max is equal to false and we will be inserting that into this. So nappies will be inserted here. So in the same way, all nappies, what are all the nappies combinations will also be added. Now, if max is equal to true, then we say, then M is equal to M union I. M union I. So then only we add I to M. So remember, our M is empty and our resultant frequent set item is M. So this is how written M. This gives us total return. Frequent item sets will be returned. Okay, let us again check. The algorithm maintains a priority queue, initially holding only the empty item set. Empty item set, I think you all might be knowing. This is empty item set, which covers all transactions, my dear friends. All transactions, that is very important. All transactions. Now, taking the next candidate item, set I of the priority queue. And we are taking the empty set. Empty set. It generates all its possible extensions. All possible extensions and first, anni 9 combinations select out. See, all 8 combinations will be selected because we have empty box. Kabatti, all 8 will be selected. 1, 2, 3, 4, 5, 6, 7, 8. Right. So 8 select అయిపోయిన తర్వాత, right, you take I dash. I dash means transaction 1. Suppose sub of I dash is greater than F0. So yes kabatti. So first nappies will be added into our queue. So here nappies will be added to our queue. And then it goes again. It goes to the second item called as beer crisps. Beer crisps. We have beer crisps? 1, 2, and 3. So this also, so max becomes false and this is added into queue. Beer crisps. And then next one is apple snappies. Apple snappies, how many are there? This is 1, this is 2. So which is not not less than 3, which is not greater than or equal to 3. So it won't do. Next, it goes to the next possible. Next possible. What is the next possible? Beer crispies naples. This also, this is 1 and this is 2. So this also will not be taken into consideration. Next one is apples. Oh, 3. Beer crisp nappies. If you take beer crisp nappies, there are only 2. It will not. Apples. If you take apples, apples have got, see, this is 1 and this is 2, this is 3 and this is 4. So kabatti apples tiskuntaru, apples tiskoni, that will be added to queue. That will be added to queue and our queue becomes now apples. Next, Next, again it goes there, and again it finds apples, beer, crisp, and iదేంది పనికిరాదు తీసేస్తాం. Next, apples, crisps. Apples, crisps. If you take apple crisps, this is 1. There is no. This is 2. So we will have only 2. Kabatti we will not consider apple crisps. We will not consider apple crisps. And crisps. Last one, crisps. If you take crisps, this is 1, this is 2, this is 3, this is 4, this is 5. So we have to consider crisps. So crisps. Oh, already it has come. Okay, I don't know. Oh, such crisps. So this is how. Now, so as empty transaction is over, and max is, my dear friends, false. Max is not true. Max is false. Max is false. So again we go back here. అంటే అర్థం ఏంటి? ఈ లోపలికి ఒక్క ట్రాన్సాక్షన్ కూడా రాకపోతేనే we are going to add I. So now we are taking 1. Nappies తీసేస్తున్నాం. Nappies are taken out, and now we do the same thing. Nappies ఉన్న అన్ని ట్రాన్సాక్షన్స్ కావాలి ఇక్కడ. నాపీస్ ఇది ఒకటి, నాపీస్ ఉన్న ట్రాన్సాక్షన్ ఇది 2, ఇది 3, ఇది 4. ఈ 4 ట్రాన్సాక్షన్స్ బయట పెట్టుకొని ఆ 4 ట్రాన్సాక్షన్స్ తోటి మళ్ళీ సేమ్ ఇలానే చేస్తూ పోతే అట్లా చివరికి సో విల్ గెట్ M. So this is how we have to do, and so all possible frequent item sets will come, right, and adds them to the priority queue. They exceed support threshold, right? If at least one of I's extension is frequent, I is not maximal and can be discarded. So otherwise I is added to the set of maximal frequent item sets found. We'll get finally we will get M. M is the frequent item sets. Frequent item sets. This is breadth first search, my dear friends. Breadth first search, where we use queue instead of stack. So దాంట్లో అయితే స్టేటస్ ఒకటి పెట్టుకుంటాం. ఆ స్టేటస్ టు అంత క్లియర్ గా చెప్పరు కాబట్టి ఇక్కడ. So this is how we can easily right. Thank you.